Alright, I thought I would do a live, as opposed to a static solution of finding an exponential model and using the M and R test. So we're going to derive an exponential model for the data. Then we'll decide if that's a better one than the linear model. Right? So, and the M and R test. So you have some data, and we're going to try to find the equation, an exponential equation that describes it. So the idea is we're going to find a bunch of R values, and we're going to find them for each pair of points. So if you think about the graph of points, what we're doing is finding the R value for those two, and then those two, and then those two, and then those two, and then those two. And then we average them all together because some of the R values are higher than others. So the hope is that if you find an average value, it will roughly give you the R for the curve. We'll talk about B in a moment. So let's see, I need my calculator. All right. I'm going to do the first couple, and then I'm going to pause the video and finish the table, and during that time you can pause and try filling the table out as well and see if yours matches mine. We'll do to 3 decimal places. So here's the idea. The formula we're using to find R is y2 over y1 raised to the power of this. And I made this data pretty messy. The independent variable, whatever, it's apples, and it increments unevenly. It goes up by 2, goes up by 3, goes up by 1, 1, 1, 2. As we know from class, if it goes up a regular amount, this whole process is a little faster. But I wanted to really flesh things out here. So the first R value concerns these 2 points. So it's 1.5 over 1 raised to the power of 1 over 5 minus 3. So that's 1.5. So 1.5 over 1 is itself raised to the power of 1/2. So what's that? 1.5 raised to the power of 0.5. That's 1.22. I'm going to round to 3 decimal places. So 1.225. All right. Now the next one. So that will involve those 2. So it's 5 to the 1.5, not 2, 5 over 1.5 to the power of 8 minus 5. 8 minus 5. Okay. So let's see. So I can break this up into steps. I can do 5 divided by 1.5. Right? That's going to be 3.333. And then 8 minus 5 is 3. So this is going to be to the power of 3.333. That's not true. 0.333. And I'll get 1.493. Rounding to the 3rd place, 1.493. I'll do one more, then I'll have you finish the rest. So now it's 6 to 5, so 6 over 5 to the power of 1 over 9 minus 8. 1 over 9 minus 8. So that's 6/5 to the power of 1, which is 1.2. Now I'm going to pause the video. You should pause the video as well and do the last 3 and see if they match what I do. Ready, set, pause. All right, and we're back. So I did a couple more calculations. I did the 8-6 pair. Then I did the 8 and 8 pair. Oops. Here. And then the 10 and 8 pair. So I have these 3 values. If you're not getting these, but you're doing these calculations, it's probably a calculator mistake. Now, how do you know if it's a calculator mistake? Well, try doing something you know the answer to. For example, if you know that 3 to the 0 is 1, try doing 3 to the power of 1 over 1 minus 1. If you don't get 0, if you get something else, like 2, then you're probably entering it like 3 raised to the power of 1 divided by 1 minus 1. And then your calculator will do something like this. Exponentiation first, that's 3, minus 1 is 2. So if you're not getting the right answers, the same answers, and you think you're using the calculator incorrectly, do something on your calculator you know the answer to, and then see if you get the right answer. If you don't, well, then it's probably a calculator issue. Okay, now for the b values. So what I'm going to do is recopy all this on a separate sheet of paper and then do the b values. And we're back. To find b, we use the equation. So to find b's, we need a lot of them. We use y equals br to the x. We know r. So in our case, we have y equals b 1.228 to the x. And then for each of these points, we're going to substitute the points in here and generate a b. So for 3, 1, we'd have 1 equals b 1.2283. And then we can solve this for b. 1 over 1.228 cubed equals b. So what's that? 1 divided by 1.228 cubed is 0.540. We'll do 3 decimal places here too. 3 decimals. 0.540. Right. Let's do another one. So for the next point, for 5, 1.5, when y is 1.5, and when x is 5, we can solve for b. So this would be 1.5 over 1.228 to the 5th. So let's calculate that. Equals b equals 0.537. So 0.537. And again, I'm going to do a couple more and then have you finish the chart out. So for this one right here, 8, 5. So when y is 5, we can find a value of b. And each time we're using the same average r that we've already calculated. So 5 divided by 1.228 to the 8th power equals b. 1.228 raised to the 8. Whoops. That's 0.967, rounding to the 3rd decimal place. 0.967. Okay, why don't you go ahead now and pause and see if you can finish the table out, and then I'll come back. Ready, set, pause. All right, we're back. I have my calculations. I filled out my r's, and there's my average. So at this point, we have everything we need for the equation. The exponential model of the data is 0.792 times 1.228x. The idea is that this will describe, as best as possible, this data with an exponential model. Now, if the data isn't exponential, then the model will do a poor job. If it's kind of exponential, it'll do a medium job. If it's exactly exponential, it'll do a perfect job. But of course, data is seldom ever exactly anything. Alright, so anyway, find your r's, find your b's. Now the m and r test. So here's the next bit. For that, we need not only these r's, but we also need the m's. And the m's are also done pointwise. So let me go ahead and grab another piece of paper here. In fact, let's cover up the B's. We don't need those for the M and R test. So for that, for the M's, once again, I'm going to do pairwise. And here we're just using the familiar y2 minus y1, x2 minus x1. So for example, using these first two pairs, we'd have 1.5 minus 1 over 5 minus 3. So that's a half over 2 is a quarter. So our first slope would be 0.25. And then our next one would involve these next pair of points. That would be, that would be 5 minus 1.5, 8 minus 5. So that's 3.5 minus 3. Oh, what's that? 7 halves. 7 halves over 3, so 7/6. That doesn't, is that 1.17? Yeah, so 1.17 if we're keeping 2, or 1.167 if we're keeping 3. So in this fashion, do one more. We're going to compute slope between pairs of points. Here's one more. We'll do 6 minus 5 over 9 minus 8. That's 1 over 1. So let's fill out the rest of this table, find the average, and then I'll show you what to do next. Okay, so ditto the M's. I have an average. Again, check that yours are the same. Now for the M and R test, the idea is to use these two expressions. These two expressions measure a couple things. They measure, one, the spread. How far apart are the smallest and biggest values? But to interpret that, what if the spread is 1 or 10 or 100? Is that a lot or a little? Well, we have to compare it to something. There's no such thing as a small number or a big number. There are smaller numbers and bigger numbers. It all depends on what you're talking about. So we divide by averages to compare the spread. So if we're going to compare the spread of slopes, we'll compare it to its average. So our smallest slope is 0. Our largest is 1.1 is 2. So this would be 2 minus 0 over an average of 0.903, and we'll multiply that by 100. So that'll be 2 divided by 0.903 times 100. This is 221%. That's a lot. Why is that? Well, if your average is about 1 and you have slopes that are 0 and 2, well, they're 100% to either side. 100% less or 100% more. So that would give you a 200% spread. What about R? Our largest value of R, this is 1.493 minus the smallest value, which is 1, divided by the average, 1.228. Multiply that by 100. Let's see if this is any better. 1.493 minus 1 divided by 1.228 times 100. And this is 40%. Does this make sense? Well, the middle is 1.2. The smallest R value at 1 is only a piece of this, right? Maybe about a quarter or so of it. And then the largest value at 1.5 almost is again about the same distance away. So 40% seems pretty reasonable. What do you do with these numbers? This number compared to this number, so you can think of this two ways. I'm running out of time in this video. The slopes have a larger spread than the growth factors. The growth factors are more tightly clustered together, meaning the data is more likely increasing according to an exponential model than a linear model. It might not be an exponential model that's best, but out of the two choices that we have, the values for the exponential growth factors are more tightly clumped together, and the slopes are more wildly spread apart. And that's 15 minutes.